Okay, so final short video. This is again something that we have seen before. We have seen many times when we have looked at all the methods and libraries of Python, but we have not seen it formally. Okay, so I'll just explain what it is, and examples are all the examples that you have already seen in this course so far. Okay, so this is called object-oriented programming. Okay, or in short, OOP. All right. So it's an idea, it's a concept. Okay. What is object-oriented programming? So it helps in dividing your program into smaller blocks, smaller parts, which makes programming easier, writing the code easier, reading the code easier, understanding the code easier, everything, changing the code easier. And in general, the Python codes will work faster when you use OOP. Okay. So what is this? Object-oriented programming just says that your Python codes gets broken down into objects and properties of objects. That's all. Okay. What kind of objects are we talking about? So this, I'll share this link with you in MS Teams, as well as the SciPy links from before, but read through it. But the very basic thing that we should know is, what are these objects? These objects are exactly those vectors, arrays, matrices that we create. These are the objects. Okay. What are the properties? All these parameters, length, number of zeros, number of non-zeros, right? Maximum, minimum, these are all attributes. Okay. What are methods? Methods are the functions that we apply on them. Right? For example, sorting an array, forming a graph out of a matrix, adjacency matrix, right? Computing geometric mean, arithmetic mean of an array. These are all methods, these are all functions, these are all methods corresponding to that object. Okay, so here they have given an informal example, but we have much better examples to think about. Okay, the main thing to understand is all objects have certain types. So array of numbers has a type. That type is that it is an array of numbers, right? A matrix has a type. The type is that it is an array of arrays. You see, a matrix is a collection of arrays, one array for each row in NumPy. So that matrix, the type is that it is a collection of arrays. All right. So that is the idea. And when I say type, that is what they mean here by a class. Class simply means type. Okay. And we can formally define a class. So here they say, they give a very simple algorithm where they say there is a class called parrot. Okay, what is this class? Well, this class has several properties. One of the properties is that it will tell you what is the species. So species is bird. Okay, and what are the properties, main self properties of any object of this kind for any parrot? It is name and age. Okay, so these are called instance attributes. What are instance attributes? These have to be given as data the moment you create an object. For example, when you create a NumPy array, you have to give the entries of that array as initial data, right? That is the instance attribute, the initial data that you give. Okay, and those are always given by using this function underscore underscore init underscore underscore. Okay, that's the lang. That is how you mention it in Python, and it is sometimes called a constructor. Okay, sometimes it is called a constructor because it constructs that object using your given information. This information can change. This is for parrot. For array, it will be numbers, or length. For matrix, it will be dimension, anything. But it constructs the object with certain parameters. Therefore, it's called constructor, and it is usually denoted in Python as underscore underscore init underscore underscore because it initializes the object. Okay, and this is how you define any function. DEF, define any function, parameters, colon, and then the data, right? We have defined functions before also, but we'll see some more examples. This is how every function is defined. Okay. Now, how do you create objects in this parrot class? Just as you did, BLU. So for example, BLU is a parrot with these properties. WO is a parrot with these properties. We have done this. We used to say ARR is equal to np.array something, 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 right? That is exactly what we were doing. So for us, the class was np.array, and then it had several attributes. Okay, whenever we created an array, it would call this constructor underscore underscore init underscore underscore and fill the data into it. Okay, and then you can do whatever you want with that object, print or access or whatever, depending on what the object is. Okay, so we have seen objects, just that we have not seen them for. Every object that you create is an object in this sense, object-oriented programming. It has a class. What is the class? It's basically the type of that object. Here it's parrot, there it was array, matrix, adjacency matrix, CSR matrix for graph. We created an object called CSR matrix using an array. That is another object, right? So everything in Python is an object of a certain kind or certain type. That type is the class. That's it. And the objects, when you create them using equality inside Python, they are created using this function underscore underscore init, which is called constructor. Okay. Now these objects can have several functions or several methods as they are called. For example, if you create array, array has several methods. It has length, it has maximum, it has minimum, right? It has, you give an index, it will give you the value of the number at that index of the array, right? These are all functions, these are all methods. Inside Python, inside the definition of, for example, np.array, each of those parameters, maximum, minimum, length, all these are defined this way. Each of them will be a separate function. Okay, and those functions are defined this way: DEF, and then the name of the function, then the properties that you need, and then the definition of the function. Okay, exactly the same for each object that you see. Okay, think of it in terms of np.array and then CSR matrix, or the things that we have seen in NumPy and SciPy, and it will be very, very clear to you. We have seen these objects before. Okay, each of those methods in the NumPy SciPy libraries are functions. They all have definitions of this kind: DEF space, the name of the function, properties, and then the final definition. Okay, and that's exactly how you use it. So blue is an object of the class parrot. Now you want to have the function sing, and you say blue.sing. Okay, we used to do this for string. Remember, we used to say str.split or str. something else, concatenate or anything like that. Remember? So these are all functions corresponding to those objects. Okay, so just go through the Python standard library as well as NumPy and SciPy, and you'll find all these examples of classes and objects and their functions. Okay, you have seen these examples. Go through them again and try to find out what is the class and what are the objects and what are the methods. Okay, that will be good practice for you in understanding what this is. All right, only two more things about objects that I want to talk about, which is inheritance and polymorphism. Two very, very simple things. And for this, you only need one example. Okay, only one example. In Python standard library, we had this module called math, which had mathematical functions. But if you have done the tutorial properly, you will know that in the Python standard library, there is also something called CMath. CMath is for complex numbers, right? That is the idea. So inheritance is a way of creating a new class for using details of an existing class without modifying. The newly formed class is a derived class or child class. Okay, the existing class is a base class or parent class. So CMath will have everything that is already in math, because mathematically we know that every real number is a complex number, right? So in CMath you should be able to do everything with real numbers also, not just complex numbers. So everything you can do with real numbers in math should already be present in CMath, and CMath will have more things for complex numbers, right? So you don't have to repeatedly write all this definition. All this definition is there for the class math, but you don't have to repeat these definitions for the class CMath, right? For example, here, there is a class called bird. There is a class called penguin, which is a child of the class bird. You don't repeat these definitions for this class. These definitions are already coming by just by just mentioning this, right? So the first one is like math class. The second one is like CMath class, which is a child of math class. Everything that is defined for math is already taken for CMath also. So CMath is a child class, and in addition, it will have some other operations corresponding to complex numbers only. For example, finding the argument of the complex number and finding the complex conjugate, things like that. Okay, so that is inheritance, creating new classes from existing classes. There is one more clear example, very easy example that you can understand. When we were doing SciPy, I told you that NumPy is a subset of SciPy. Everything that you have in NumPy will be there in SciPy, right? That is exactly what it is. Again, NumPy and SciPy, they are libraries, but they have to be written down as a class, again as a type. Okay, so when you say np.array, array is a class, right, for which you create objects. But the class is also contained inside another class. So array is contained inside the class NumPy. Okay. And now everything that you have defined for NumPy, you need in SciPy. And SciPy has more things. For example, SciPy gives you CS graph. It can compute connected components. These things you cannot do in NumPy. But everything that you do in NumPy, you can also do in SciPy, because NumPy is contained inside. So SciPy is a child class of NumPy. Okay. I hope the inheritance thing is clear. Creating new classes from old classes, or creating child classes from parent classes. Examples: SciPy is a child of NumPy. Another example: Python CMath is a child of Python Math. Okay, very, very simple examples. Okay, very related concept is what is called polymorphism. So there is something called encapsulation here, but you don't have to look at this. This is not so important. Okay, slightly complicated and not so important for us. Let's simply look at the next one, polymorphism. Okay, what does polymorphism say? So read this again. Polymorphism is an ability in object-oriented programming, OOP, to use a common interface for multiple forms of data types. Multiple forms. So here they give a very simple example. Suppose we need to color a shape. There are multiple shape options: rectangle, square, circle. But we want to use the same method to color any shape without really bothering about the shape. This concept is called polymorphism. Okay, we have seen examples of polymorphism again when you look at math and CMath. Why is that? When you say addition, you want to use the same operation plus for addition in your Python code without bothering whether the two numbers are real numbers or complex numbers. The plus symbol should work as addition for everything, right? So that is polymorphism. Data types are different. Floating point number, that is the real number. Complex is complex number, that's a different data type. But for different data types, you don't need different functions for addition. You just use the same plus as your function for addition, right? That is the notion of polymorphism. The same function can be used for multiple data types. Best example is just math and C, everything. Addition, subtraction, multiplication, division, taking powers, taking absolute value, all these things. Another example, arrays, right? You don't want to care about what are the entries of the array. Depending on the entry, the data type of the array is different. Array of integers, array of strings, array of something else, we don't know. But many functions work for arrays without looking at the data type, length of the array, or if it's a matrix, array of rows of arrays, then the dimension of the array, whether the array is empty or not, is empty, that function. All these things will work or should work without looking at the data type. So these functions can be written down without specifically mentioning what is the data type of the object. That ability is called polymorphism. Okay, the ability to write down a single common function for multiple data types. That is polymorphism. Okay, so here we are given a very simple example for class parrot and class penguin. Okay, both have functions called fly and swim, and they have different definitions. Okay, the print statements are different, but then you don't really have to specify them separately. You can simply say define flying test bird and bird.fly. That bird could be a parrot or a penguin, depending on how you define. That is their very simple example in this tutorial. But we have already seen much more complicated examples of polymorphism. Okay, we are already at an advanced level. So we have already seen polymorphism from math to C math, as well as in arrays for different data types. Okay, so that is polymorphism. All right, so that's it. So inheritance and polymorphism, and they are quite related concepts because the examples are also very similar. Okay, so that is it about object-oriented programming that I wanted to tell, because I did not mention it in the beginning of the course because this is little bit advanced to understand to just start teaching. But now you have actually learned object-oriented programming without mentioning objects and classes. You have already learned it via your examples in your lectures and tutorials. Now you just simply go back to them and identify what are the classes, what are the methods, what are the objects, where do we have inheritance, where do we have polymorphism. Just go back in your video lectures and slides and codes and tutorials, and you will see many of these examples. Okay, so that is it about object-oriented programming for our course, and this is the end of this course. Okay, there are no more lectures. This is the end of this course, and best of luck for your exams. So I'll stop here.